We have just established that if you buy proportional reinsurance, then the ruin probability decreases by a factor 8 when you reinsure half of your business by paying away half of your premiums. Now, in D, we want to consider how the ruin estimate changes if instead of buying proportional reinsurance, we buy fixed deductible reinsurance, also called excess of loss reinsurance. And the setup we're playing with here is we assume the reinsurance premium rate is 1/2. So assume that the premium for reinsurance is 1/2. And we assume that, well, the way a fixed deductible reinsurance is designed is that your self-insurance function is given as minimum of the claim size and some deductible B, whatever is lowest, where B is some deductible. And the way it works is that as long as you have a claim size that is smaller than B, then you pay for the entire claim. However, as soon as the claim size exceeds B, then you only pay B, and the reinsurance company takes care of the rest. So what I've drawn here is a graph of the self-insurance function in the case where we have a fixed deductible reinsurance. Now, this is also just the type of insurance actually that you buy for your bike, where you have a deductible, for example, of 1,000 kroners, and the rest is then paid by the insurance company. So in the fixed deductible reinsurance case, it's just the insurance company pays the claim X until the claim X exceeds B, then the insurance company only pays B and the reinsurance company takes care of the rest. Now in the exercise text, they say assume that B is chosen. So assume that the deductible has been calculated in such a way that the mean value of the self-insurance function, such that the mean value of the self-insurance function, so the minimum of our claim and B, is actually just equal to the mean value of half of the claim. The reason why this is significant is because then we can compare this fixed deductible reinsurance to the proportional reinsurance. Because if we assume that our self-insurance function has the same mean value as the self-insurance function in the proportional reinsurance case, so this is the expected self-insurance function in the proportional reinsurance case. Well, then the expected value of the total capital is the same, regardless of whether we buy fixed deductible or proportional reinsurance, because in both cases the premiums are equal, and in both cases the expected claims are equal. So then the fixed deductible reinsurance and the proportional reinsurance can then be compared in terms of which gives a better ruin estimate. So if we assume B is calculated such that the total claim size ends up being the same on average in the fixed deductible and the proportional reinsurance case, then the total capital has the same expectation regardless of whether we buy fixed deductible or proportional reinsurance. And thus, we can compare the two in terms of their ruin estimates. So let us compare the two in terms of their ruin estimates. Now, the first thing we have to consider is the claim size that the insurance company now pays, is this claim size heavy-tailed or is it light-tailed? Because in this case, well, we now have CT is equal to U plus a half T minus sum up till NT tilde of the minimum of Y tilde I and the deductible B. And, well, here we can note the claim size minimum of yi tilde comma b, well, it actually has an upper bound because your self-insurance function does not exceed b. So the claim size is bounded, hence has a light-tailed distribution. And because it has a light-tailed distribution, we can make use of the Kremer-Lundberg. We can make use of the Lundberg inequality. Which tells us that in this case, the ruin probability is bounded by e to the minus RU, where R is the adjustment coefficient, which needs to be calculated in terms of the moment generating function for this claim size, and so on. So we just need a qualitative expression here, and what's important to note here is that in the case of fixed deductible reinsurance, well, the ruin probability is bounded by something which has exponential decay. And exponential decay is much stronger than polynomial decay as we have in the proportional reinsurance. So as long as U is sufficiently large, we have a smaller probability of ruin with fixed deductible reinsurance compared to proportional reinsurance. And it actually also kind of makes sense because with a proportional reinsurance, if you have a very large claim of like $1 million or something, then you always have to pay half of that claim. So any potential claim can be unbounded, right? However, in the fixed deductible case, you cannot pay more. You do not risk paying out more than the deductible, and therefore your risk is in some way more bounded. So intuitively, it also makes sense. And we also have from the Lundberg inequality that in the fixed deductible reinsurance case, the ruin probability has exponential decay, which is much stronger than the polynomial decay that you see in the proportional reinsurance case.